Let's see the use of curly arrows. Now, the curly arrows, they will show the movement of electrons. It's always electrons that is going to move because electrons are small, so they are able to move, while positive charges, like for example, H plus will actually contain the nucleus. So the nucleus is heavy. So the proton is more heavy than the electron. So it's easier for the electron to move. So the curly arrow is always from negative to positive. This is very important. And the tail of the arrow is the site of the negative charge. So this is where it begins. And the head of the arrow is the site where the electron is going to go. So electron is going to go towards a site of positive charge. So it's always from negative to positive. So there's two types of curly arrows. There's the normal curly arrow. So this is like this. So it shows movement of a pair of electrons. So two bars like this. So it shows two electrons moving. While half curly arrow is generally for a single electron moving, and this is when you have free radicals, so you have only one bar here in the head. So this is a half curly arrow, this is a complete curly arrow. This is generally for negative charges or for lone pair of electrons. So for example, you have H and Cl. Let's say we're looking at a heterolytic bond fission, so we are breaking the HCl bond. So HCl is like this. So you have both electrons in the bond that go to the Cl. So this is why you have that arrow that starts on the bond and goes into the Cl. So it starts on the point of the negative charge. So the starting point of an arrow is always going to be a negative charge, or you have lone pair of electrons, or a bond. So a bond like this here, a bond is a region of two electrons, so a region of negative charge. So the starting position can be a lone pair. It could also be so a lone pair or a bond pair. The ending position is going to be a region of positive charge. And so you can have a positive charge like this, so it ends on the chlorine, or it could be a region of delta plus. So here the carbon has a partial positive charge. But the ending position can also be on an atom. So it can be on a particle of another compound, or in that same compound. So it's just moving of the negative charge. So just like here, it starts on a bond and it ends on the other atom in that molecule. So here you have H now has lost the electron, so it becomes H plus, and the Cl has gained that electron, so it has become Cl minus. Here you have the Cl minus, so negative means there's two electrons, so these two electrons are actually forming a bond with the carbon, so then you end up with Cl forming a bond with carbon. And over here you can have the arrow that starts from that radical, and because it's a radical, so you will have half curly arrow. So it starts from here, it's going to end on the hydrogen. So there's going to be a bond that is formed between X and hydrogen, okay, which means that the hydrogen is going to uncombine with that carbon, which means that, so this bond, so you have half curly arrow here, you're going to have another half curly arrow, so this electron here is going to go on the carbon. So here you end up with, so let's say this is H, so you end up with CH3, and then you have that curly arrow, you have that one lone pair that is left, so you have a radical which is formed. Okay, and this one electron over here, this one electron, this is what pairs up with this here. So this is why you have that bond here. So you have that one electron over here, sorry, that one electron over here and that one electron over here, that form a double bond, a single covalent bond. And then this one electron here, that is going to go on the carbon, forming the radical. Okay, so this is a bit how we're going to be applying arrows.